Exponential and logarithmic functions. Example 1. Simplify the expression. To simplify, that means perhaps make it not a quotient, make it less stuff. So, first thing I notice is that we have the cubed root symbol. This will be easier to write if it's in exponential form, like all of the other terms in this expression. So let's rewrite this as 9e to the negative 3x plus e to the 7x, same numerator, divided by, instead of cubed root, we can write this as 27 e to the 12x all to the 1/3. That's what cubed root means. Now I can simplify this denominator first. So this numerator, I'm going to continue to write. Every base gets this exponent 1/3. 27 to the 1/3 means cubed root 27. Of course, that's where we got it. And the cubed root of 27 is 3. E to the 12x to the 1/3 means that we're multiplying the 12x times the 1/3. So that's going to look in the denominator like e to the 4x. 1/3 times 12x is 4x. Let's continue. We can break up this numerator by dividing both parts, both terms, by the common denominator. So this becomes 9e to the negative 3x divided by 3e to the 4x plus e to the 7x divided by 3e to the 4x. Kind of like distributing, because division is a form of multiplication, it is distributing. 9 divided by 3 is 3. When we're dividing and they have the same base, we subtract these exponents. So negative 3x minus 4x makes negative 7x. So this new exponent for e is negative 7x. Plus, this is 1/3. Again, we're going to subtract these exponents. 7x minus 4x makes 3x. So this is e to the 3x. This is simplified, and we're done. This simplification is going to make it easier for us when we're dealing with these terms for derivatives and integrals. Example 2, expand the expression. So when we have a natural log function, for our purposes in calculus, it's going to be easier if it's not clumped up like this, but that we can spread it out. And with a natural log function, we have the properties to be able to do that. So first thing I'm going to do is rewrite the fifth root as the exponent form. 3e sine cubed x divided by 3e plus 1. All of that is to the 1/5 because it's fifth root. Now my property of log with the exponent tells me I can move that exponent out to in front of the log. So I'm going to do that next. 1/5 times the natural log of the quotient 3e sine cubed x over 3e plus 1. Now because this is a quotient, I can split it up with subtraction. So 1/5. Because I'm going to break this up into two natural logs, I'm going to need to put the big brackets because the 1/5 is times this entire expression. So the 1/5 will be multiplied to this entire expression. Numerator first, 3e sine cubed x minus, because of the division, natural log of 3e plus 1. Notice that from what was in the numerator, I have a product of three things. 3, e, and sine cubed x. So I'm going to break that up using the natural log properties. 1/5 natural log of 3 plus natural log of e plus natural log of sine cubed x. But I'm going to write that differently. I'm going to write it as sine of x function cubed. You'll see why in a moment. Then I'm going to finish writing what was already there, minus natural log of 3e plus 1. Now I can simplify these parts that I broke up. For this part, again, I have that exponent I can bring in the front, and the natural log of e equals 1. We should know that. This is 1/5 times the quantity natural log of 3 plus 1 plus 3 times the natural log of the sine of x minus the natural log of 3e plus 1. Why didn't I do anything with this? Because it's not a product or a quotient or a power. This is a sum, and I cannot break up a sum, so I'm finished. I've expanded as much as I can